Great. Thank you so much.
Okay, thanks everyone. So remember that when we're doing science communication, we have to be doing it all the time. As far as I can tell, George is the only other person with a science tie. Right? I've got the West Nile virus here, so you can buy these downstairs in the gift shop. And a couple of people in the first panel made the sort of stock apology of they felt like they were talking to the people who had done the studies that they were talking about. I have to admit that I'm feeling a somewhat similar way in the sense that the talk I've prepared is for people who haven't quite yet learned how to think about science communication and aren't quite aware of some of the data. I'm beginning to get the sense that people in this room already do know a lot of that stuff. So a lot of this may look familiar, but explain what it is trying to set up here. The question is that has come up, what's the problem we're trying to deal with? People have talked about the fact that the academies have been publishing reports on this since the 50s. The first scientists and journalism workshop that I'm aware of was the proceedings were published the year I was born. And there's a fair amount of gray in my hair, so that gives you some sense. There is a history to this, to talking about what the problem is, but that history can limit us. And that's the point I want to make, which is to say that in the years after World War II, which is when people started talking about public understanding of science, there were a bunch of different groups who were doing it, publishers, science journalists, scientists, government agencies, and pretty much what they all meant was, when they used the term public understanding, they almost always meant public appreciation of the benefits that science provides to society. And as I said, some conversation earlier, I don't necessarily disagree with that, but as an analyst, I think it's really important for us to recognize that there's a meaning to these words. The current sort of wave of research that was in one of those nice citation charts that I think May put up, really the social science research took a big jump up beginning in the mid-'80s, in part because of a report from the Royal Society, generally known as the Bogner Report. The technical title is Public Understanding of Science, which had these statements like this one: hostility or even indifference to science and technology weakens the nation's industry. That's the problem, which then needs to be addressed. And they had similar statements for dealing with whether people could talk about personal decisions, or they would talk about science policy issues, or whether they would talk about science and culture. This generally perceived perception in the science community that there's a problem with public understanding, that science is not being used enough and needs to be addressed. Because that perception was in the science community, it fairly frequently then came with the sort of, well, what's the solution to this problem? The solution is more knowledge. We think people just don't know enough science, and so there was this thing that if we just pour knowledge in, many of you have heard this, the deficit model, the idea that people just don't know enough. If we pour knowledge in, that will fill the deficit, and then everything will be better, whatever everything is, and whatever better meant. And it was just unclear whether we meant better appreciation or better attitudes, better use of science, better uptake, more agreement with the positions that mainstream scientists would have, whatever. But all of this then led to a tradition of measurement, and that's where this sort of social science stuff comes about. And so there have been many measurements now of knowledge, attitudes, and interest in science. Some of the data we've already seen. Just to give a sense of where this started, the first of these measurements was done in the 1950s. The National Association of Science Writers, the journalists, pushed for a survey that was funded through NSF. It happened that they went into the field in the late spring, summer of 1957, and therefore when they were just getting their first results back when Sputnik went up, and they got another supplement so they could do another field study 6 months later, so they had a before and after Sputnik measurement. But then basically nothing much happened again until the early 70s, and then NSF got a sort of sputtering start, and then beginning in 1979, for the science and engineering indicators, every 2 years, there has been a chapter on public knowledge and attitudes towards science. As many of you know, a lot of that work was built on the work of John Miller, now at the University of Michigan, and John had some evolving ideas about what science literacy is, and it's really important that we understand that even though a lot of the current research has moved beyond what John does and what his interests are, and therefore can sound like it's very critical of him, but it's really important to recognize that what he did was create a longitudinal database that is one of the best we have. Certainly in this area, it's the only one we have, but it's actually pretty good in other areas of public opinion as well. So I think it's important for us to recognize the value of that. He had a definition of what knowledge would be, what kind of knowledge would you need. In those days, the label was to be scientifically literate, that you would need some basic factual knowledge. You would need knowledge of science as a process, by which they meant the scientific method defined in various ways. And then there was this idea of knowing something about particular issues where science and society intersected, knowledge about whatever the hot button issues of the day turned out to be. That would be both a knowledge measure and an attitudes measure. What did people think about it for various topics, and the topics have varied over the years. Again, a lot of you have seen this kind of data. This is the factual knowledge of science. Do people know things? When you look at questions like, do people know that the center of the Earth is hot? Do they know that the continents move? Do they know that the Earth goes around the sun? Pretty steady, between 70 and 80%. Gotten it right. That census data is from 85 through 2010. So pretty steady. Then there's this other cluster that's down here in the 50% range where you get issues about electrons smaller than atoms, and does the universe begin with a big explosion, and of course our favorite one, did humans evolve from another species, which is down here, which is about 45%. The only one that changes really over this time period is the antibiotics one. People understand fairly well, much better than they did. Not well, but still 50%, but better than they did. That the antibiotics do not kill viruses. The thing to notice about these, so everybody gets all upset about these. There's the political issues about the wording of the Big Bang and the evolution question. The important thing that I think to really take from this is how steady this has been over the time period that's been measured. Is there's really been no change. And there are two possible interpretations of that. One is that despite all of the incredibly good and exciting science communication efforts and public interfaces we've had over the last 50 years, hasn't changed a thing. The other possibility is that it would have been much worse, and those things have kept us steady. I have no way of knowing. The second of those criteria was that were measured was the question of, do you know the scientific process, divided into issues of do you understand some basic probability, if a couple has what's the probability, if one of their children has a genetic disorder, what's the probability of the next one having it? Second off, do they understand something about the nature of experiments, and can they describe what it means to study something scientifically, with the right answer being things like theory. It involves theory testing, or it involves experiments, or it involves systematic data collection and comparison. All of that got combined into a composite measure of knowledge of science inquiry, which again has actually jumped up. This data is from 99 on to 2010. Again, pretty steady actually over the last decade anyway, that we have that composite measure. Then there was this issue of looking at specific topics. And here things get a little bit trickier. So these tend to be attitudes, they've actually mostly dropped the questions about knowledge within certain topics. They tend to focus on attitudes. This is stem cells from 2001 to 2010. This is strongly favor stem cell research, and this is somewhat favor. And what you're actually seeing is there's a general growth in that over the 10-year period. It's a little, it's not dramatic, but there's definitely some growth in that. This is public attitudes towards conducting human health research that might inflict pain or injury on animals, lab animal issue we raised. There's been a dramatic drop from 88 to 2008, that people are agreeing that that's a reasonable thing. So there you begin to see some of the complexity, that it's not straight knowledge. This is public interest in various issues. It's messy. I tried to make the lines a little bit heavier. This is medical research here. This is interest in environmental pollution. This is 81 to 2010. Both science, this is new scientific discoveries are here, and this one is new inventions and technologies, and fairly steady across, at about 40% across this time period. So the interest remains, again, fairly constant. And then some things go up and down as well. So the question that has emerged is, are knowledge and attitudes actually tied? Does all of this measurement of knowledge and measurements of attitudes, are they tied? And that answer is, So Nick Allam is a researcher in the UK, he and some colleagues did a meta-analysis a few years ago looking across multiple countries, and this was their conclusion of the literature. They tend to show that people who are more scientifically literate, that is, have more knowledge, have more positive attitudes towards science in general, but not necessarily more positive about specific applications of science and technology. And that's the limit. At the same time, they were trying to, they said that. Then they also were looking at how strong is the tie between knowledge and attitudes. And I'm not going to try to explain this except to show that the closer you are to this horizontal line, I guess the lower you are, the less strongly tied knowledge and attitudes are. The USA is here. We are not only by far the highest, but actually noticeably higher than most other countries, that more knowledge and more attitude. Knowledge seems to be tied to attitudes. Again, that's generally science. If we start looking at these specific technologies, then things start getting messier. So this was biotechnology. This was opinions on various applications of biotechnology. How useful are these applications, and how risky do people perceive them? And what you see is it sort of jumps all over. There actually isn't a very clear trend here about whether people attach utility and risk. They vary, so that the highest utility one is using genetic testing to detect diseases. That one's seen as less risky. On the other hand, the next highest one is cloning human cells to replace a patient's diseased cells that are not functioning, and that one is both the second highest in utility, but also the highest in perceived risk. So you're seeing there's not this direct link between these things. When you start looking at something like stem cells, what you begin to see is the the way in which other kinds of value issues that Alan brought up are really fitting in here. So when you ask people, if people are not very well informed about stem cells, there's a sort of yuck factor, sort of an immediate, I'm not sure. As they become more, and so this is level of support, if you move them into a highly informed, highly aware, just more aware of the issues, they become much more supportive, especially if they're non-religious. If they are moderately religious, not quite as much support, but we're still up here in the 60 to 80% range. If they're highly religious, there's almost no change. So religion turned out to be the defining issue. Something very similar happens with ideology. Again, same measurement. The gap for the conservatives, so we have here liberal, moderate, conservative. Conservatives, it's not quite as dramatic as in the religion, but clearly the slope is not as high. There's not as much of a gain there. So we begin to see that other issues come in. This one is agricultural biotechnology. You'll notice, by the way, the names on some of these, Matt Nisbet, who's actually a member of our committee but couldn't be here today, and who's a student of Dietrich and mine, and Dominique Broussard, who's one of my students and now one of Dietrich's colleagues. You'll see these names popping up over and over. The question is, what's their support for agricultural biotechnology? And factual knowledge is only explains 9% of the variance. Whether they trust the biotechnology sponsors, that's 17%. The word trust has begun to come up a few times, and we're seeing that. Whether in general they're concerned about the impacts of science and technology, that's 22%. And the highest one, 32%, is how much are they willing to just defer to scientific authority? Do they accept the authority of science? Or are they looking for a source of authority in some cases? That tends up to be. The details are less important than seeing that it's not just facts. It's lots of other things that are coming in here. Work that Dietrich and I did on nanotechnology, Dietrich, again, is there, what's leading to support for research? Knowledge was not significant. It turns out to be other things like media use and their interpretation of the benefits. So a judgment about risks and benefits and so forth turns out to be the critical thing. So, to conclude, in 10 minutes, we do know a lot about knowledge and attitude. I've given only a very small sample of some of the studies. There's a lot more done by not just our students and immediate colleagues. And there's enough to know that it's not a simple relationship, that just adding in knowledge is not going to solve the problem. And instead, in fact, we have to define what the problem is. And that's the issue. Is this, as we started to talk about in the last session, is it science's problem? Is it a societal problem, in which case, why do we as scientists get to claim it as being particularly ours? To some extent, right, you know, I'm a researcher. My conclusion is always going to be more research is needed.